This micro-credential deals with automated manufacturing control systems and consists of 5 targeted skills. This targeted skill deals with programmable automation systems. Programmable automation systems, also known as Programmable Automation Controllers, PAC, are advanced control systems used in industrial automation. These systems combine the capabilities of programmable logic controllers, PLCs, and personal computers, PCs, to provide a flexible and powerful automation solution. Programmable automation systems are widely employed in various industries, including manufacturing, process control, and infrastructure management. There are several key features and benefits of programmable automation systems. One of the primary components of programmable automation systems is the programmable logic controller. PLCs are specialized industrial computers designed to control and monitor machines and processes in real time. They are programmable using ladder logic or other high-level programming languages and allow engineers to create complex control algorithms and logic sequences. PLCs provide precise control over machines, motors, sensors, and other devices and enable efficient and reliable automation. In addition to PLCs, programmable automation systems incorporate personal computers to provide additional computational power and connectivity. Personal computers, PCs, serve as the user interface and host the software applications required for programming, monitoring, and data analysis. The integration of PCs allows for sophisticated human-machine interfaces, or HMI, data visualization, and remote access capabilities. Engineers can program and configure the automation system using software tools that offer intuitive graphical interfaces and extensive programming libraries. Programmable automation systems offer several advantages. First, they provide flexibility and adaptability. The combination of PLCs and PCs allows for easy modification and reconfiguration of the automation system. Changes can be made to the control logic and algorithms without significant hardware modifications. This should reduce downtime and increase production flexibility that is especially valuable in industries with dynamic production requirements or frequent product changes. Another benefit of programmable automation systems is their ability to integrate with other systems and devices. They can communicate with a wide range of field devices, such as sensors, actuators, and motor drives using various communication protocols, such as Ethernet, Modbus, and Profibus. This connectivity facilitates data exchange, remote monitoring, and control from a central location and improves the overall system visibility and management. Programmable automation systems also offer advanced data acquisition and analysis capabilities. They can collect and store real-time data from sensors, machines, and processes that allow for an in-depth analysis and optimization. Engineers can monitor key performance indicators, identify bottlenecks, and make data-driven decisions to improve productivity, quality, and efficiency. Furthermore, programmable automation systems can integrate with enterprise-level systems such as manufacturing execution systems, or MES, or enterprise resource planning, ERP systems, enabling seamless data flow and integration across the organization. The scalability of programmable automation systems is another important feature. They can be easily expanded and upgraded to accommodate changing production requirements and technological advancements. Additional PLC modules, input-output, or I/O points, or communication interfaces can be added without disrupting the existing automation infrastructure. This scalability ensures that the automation system can grow alongside the needs of the business plus protect the initial investment. Finally, programmable automation systems are advanced control systems that combine PLCs and PCs to provide flexible and powerful automation solutions. They offer precise control, flexibility, connectivity, and advanced data acquisition capabilities. They also enable efficient and reliable automation in various industries and allow for increased productivity, improved quality, and better decision-making. The integration of PLCs and PCs provide the foundation for advanced human-machine interfaces, remote access, and data analysis, and help to drive advancements in industrial automation and control.